Ah, hear that music? You know what that means? That means it's time to once again open up Mr.pHong's mailbag. Let's take a look and see what's inside Mr.pHong's mailbag today. Oh, we got a letter to Mr.pHong. That's me. Let's see what this letter says. It says, "Dear Mr.pHong, you have shown us a substance that is really, really cold, liquid nitrogen, at about minus 200 degrees Celsius. Wow, that's cold. Can you please show us something that is really, really hot? And how hot does it get? Thank you very much. From Alessandra C., Alameda, California." Well, Alessandra C. from Alameda, California, there are several very hot things that comes to mind. The first is Death Valley. Death Valley, wow, the temperature gets up to 120 degrees Fahrenheit, which is 48 degrees Celsius. And actually, it sometimes gets even hotter than that on record-breaking days. That is really hot. And then there's boiling water, 100 degrees Celsius or 212 degrees Fahrenheit. Let's take a closer look at some boiling water, which is really, really hot. Check this out down over here. Wow, look at that. It is bubbling. Now, most people think that these bubbles are air bubbles, but that doesn't really make sense because how would the air get inside there? This is a glass beaker and the air can't penetrate through this glass, but they just see it, oh, that's air, and they don't think too much about it. However, if you think about it, what's happening here is this beaker is sitting on top of this really hot electric element, and it's getting really, really hot down there. And once it hits that boiling point, or 100 degrees Celsius, 212 degrees Fahrenheit, these molecules of water, of liquid water down at the bottom, get so hot that they turn into gaseous water. And when it turns into gaseous water, well, it forms a bubble, and of course the bubbles, being less dense than the water, rise to the top. So, what's inside those bubbles? Not air, but gaseous water, also known as water vapor. Now that's really hot, 100 degrees Celsius, 212 Fahrenheit. But what's even hotter than that, and this is the hottest thing that I know of, is the thermite reaction. Look at this, 2,200 degrees Celsius or 4,000 degrees Fahrenheit. That is really, really hot. That is way hotter than even boiling water. If you were in a thermite reaction, you might even want to jump into a pot of boiling water just to cool yourself off. Okay, so let's take a look at this thermite reaction. I've got some right over here. This is thermite. Thermite is consisting of aluminum oxide, iron oxide and aluminum. And it forms aluminum oxide plus iron. And you might recognize this as a single replacement reaction where oxygen is hanging out with iron. Aluminum comes along and oxygen decides, hey, I want to hang out with iron instead. And so what happens? The aluminum and the oxygen get together, and left out all by its lonesome is iron. And a whole lot of heat is generated. So much heat, as a matter of fact, that this iron gets melted. Now, iron melts at 1,500 degrees Celsius. So clocking it at 2,200 degrees Celsius, it definitely is enough heat to melt this iron. And we will witness that in just a moment, because what I have in this bottle is thermite. And let's take a closer look at this thermite over here. This is that aluminum oxide and iron mixed together. It's not reacted yet. And what I'm going to do is I'm going to pour it into this flower pot over here. And notice how it looks kind of like pepper, doesn't it? Or a mixture of salt and pepper. So let's pour it inside here. Okay. And now, in order to get this to react, we're going to have to heat it up. But not with just a match. That's not hot enough. What we need to heat it up with is the special thermite igniting stick. And this thermite igniting stick consists of aluminum, a mixture of iron oxide, powdered aluminum, barium nitrate, and a binder that holds it all together. And it looks like a 4th of July sparkler. Look at this over here. But it packs a much bigger punch than a 4th of July sparkler, as we'll see right now. Follow me, and let's head on outside to do this thermite reaction. We're going to put it up on this special stand that I made. We'll put this up on this special stand that I made. And of course I want to put my goggles on. And we're going to go ahead and let's get things started over here. Now, as this thing burns, you'll see a lot of stuff coming up over here, a lot of flames up at the top. But don't be distracted, because what we'll see is this hole at the bottom of the pot, which I taped up temporarily. The hot molten iron will burn through it, and it'll drip down hot molten iron through the bottom of the pot. Let's check it out, you guys. Here we go. Okay, we are ready. Happy 4th of July, everyone. And contact. Wow, look at that. Do you guys see that hot molten iron dripping through there? Wasn't that something, you guys? And you guys can't see it, so take a look at the bottom over there. You see that hot molten iron. That's some serious heat, you guys. It doesn't get much hotter than that. 2200 degrees of pure energy goodness. Wow, I like that. Now, a couple days ago, we did the same experiment out here, and I can't touch that down there, but this is what it looks like after it cools off. It's a slab of hot molten iron. Okay, so Alessandra C. from Alameda, California, thank you very much for writing into Mr.pHong's mailbag. I hope this answers your question, and thanks for watching.